Hello students, welcome back. Right now we have a glaring problem in Broshi. On slow computers, this game is going to run a little slower. Our falling blocks are going to take a longer time to descend. And on fast computers, they're going to move a lot faster, going down our game window. And this is because we're currently processing everything in our game based on frames. We want to switch from a frame-based system to a time-based system. Slow computers are going to process less frames per second, and fast computers are going to process more frames per second. And this is going to create inconsistent gameplay on one computer to another. So instead of processing everything by frames, we're going to move to a time-based system, because on a slow computer or on a fast computer, 1 second or 3 seconds or 5 seconds of time is the same. Time is the same on any computer. And once we switch to a time-based system, this is going to allow us to create something called a difficulty ramp. A difficulty ramp is going to scale the difficulty level of our game. So the longer we play our game, the harder and harder it's going to get. And it's going to be a smooth, gradual increase from some starting value to some ending value. And we'll just increase our difficulty the longer and longer we play our game. So let's head to our lesson go jump to our computer screen to get going on our lesson here. So I have lesson 5's starter file open, our difficulty time, our delta time and difficulty ramp lesson. And so I'm going to minimize this file here in vscode.dev, and we're going to open our file directly. So I'll come over to Broshi, and we'll open lesson 5, and we'll open lesson 5's starter file. And so, whoa, right now, I'm moving really fast. The blocks are falling super fast. I see time here in the bottom HUD, but it's not updating. It seems like my falling block system is broken, and it sort of feels like my player movement system is broken as well, because everything is just being processed way, way too quickly. And this is probably because these previous systems of the falling blocks and our moving player were frame-based, and we're trying to switch over to a time-based system, and they haven't been written properly yet. So let's come back to our computer screen, and let's look at how we can make these changes. So mission 1 here, it says add the delta time variable and clamp it in our draw function. So I'm going to hit Command F, Control F to bring up our search bar, and we're going to type in mission 1 to go to our mission 1 tag. And it finds us in our P5 draw function. Remember, setup gets called once at the start of your game by the P5 library, and the draw function gets called every single frame of your game. And so if we're running at 60 frames per second, this function gets called 60 times. If it's 30 frames per second, we're only going to call this 30 times in a given second. And so what we want to do is, instead of processing things based on those inconsistent frame numbers, we are going to process it on a time interval. And so we have a built-in variable here called delta time. Delta time is a measure of how much time it took for a single frame to elapse, and it gives us that value in milliseconds, which is awesome. So we now know how much time it took for a frame to occur, but we don't really like milliseconds. We prefer seconds. So we're going to convert the delta time variable, which was in milliseconds, to seconds, and we're going to call it dt here. So dt is going to be our version of delta time, but instead of being in milliseconds, it's in seconds. So to get there, we're going to take the delta time variable, which is how much time it took to process a frame in milliseconds, and to convert to seconds, we'll divide it by 1,000. So this is perfect, but there's one issue. So like let me refresh this so I don't have all these blocks. If I'm playing my game here and I go away from that tab, and let's say I'm away from there for like 5 whole seconds or 5,000 milliseconds, when I come back, that dt variable is going to get huge, because 5,000 divided by 1,000 is going to be 5. That's substantially larger than what it would be if we were just simply playing our game. And that could cause that like huge jump in our dt variable could cause some weird gameplay behavior. So what we're going to do is we're going to specify a largest possible value that we want for dt. And the way we do that is with the min function. The min function, we're going to give it 2 numbers, and we're going to say, hey, pick the smaller of these 2. So I'm going to give 0.033, and then I'll do our delta time variable divided by 1,000. So in the instance of me stepping away for 5,000 milliseconds from my tab, this becomes 5 and 0.033. And the min function is going to pick the smaller of the two. It's going to pick 0.033. So this is like our highest value that we'll take for our time interval. And that's just going to wipe out any weird inconsistent behavior if we sort of jump away from our computer screen or our game lags, anything like that. So now that I have the amount of time that has elapsed in a given frame, I'm going to use that, and I'm going to use that time. And this is where mission 2 comes into play. So mission 2 says, hey, let's update our runtime seconds variable using DT, and also pass DT into the update player and update blocks functions. All right, so here it looks like we've got a timer here that's trying to figure out how long we've been playing the game. We're going to keep track of that, but it's not active right now. So I must have a variable here called runtime seconds. Why don't we go, I'm going to click up here to my student edit zone. Let's see what we have to work with here in this video that is new. So if I scroll down, it looks like certain variables have been converted from being processed by frames to being processed in seconds. For example, our move cooldown used to be a cooldown of 10 frames. Now it is a cooldown of 0.17 seconds. So how do we get there? Well, if we take 10 frames and we assume that we are moving at 60 frames per second, I divide 10 by 60. I can't divide by 0. I can use a calculator. I divide 10 by 60. I get 0.16666 or 0.17 seconds. So we are converting that frame-based countdown into a time-based countdown. And it looks like we're doing the similar thing for like our block waiting. So we were waiting 36 frames. That's how long the blocks are going to sit up here. Well, now we want to wait 0.6 seconds. So we just take 36 and divide it by 60 frames running every second, and we're going to wait for about 0.6 seconds. So that looks good. It looks like the block fall frames, we are commenting that out and not setting that at all. And I think that's probably because that is going to change. We're going to speed up how long the blocks take to fall because that's going to be one of the variables that we control when we increase our difficulty. Same with the number of blocks that we're spawning. So let's just kind of keep going here. Let's see. Okay, so we got these ramp constants. Yeah, we're going to make a difficulty ramp, and we're going to target their fall interval. We're going to target their spawn interval and how many blocks they spawn. So we'll look at that. In our color palette, no new colors, gameplay variables. Okay, we got runtime seconds right here. So we've got this new variable called runtime seconds, and then it looks like we got a bunch of variables for our ramp here. So let's just focus on runtime seconds right now. Now that we know what we're working with, we can go up to mission 2. Runtime seconds, we're currently adding 0 to it, so it's never changing. Well, let's add 1. I guess let's add 1 to it. Let's just see if we will add a second, right? Let's see what happens. So I refresh the game now, and well, the timer's going. I guess that's good. But it is not at all accurate because we have not been playing this game for almost 500 seconds right now. So what in the world are we looking at? Well, if you think about it, this P5 draw function runs every single frame of the game. So this is representing one singular frame. So every frame we are adding 1, which means I have run the game now for about, not 1,000 frames right now. I don't want a frame count. I want a measure of time that has elapsed. So what I'll do is I'll add DT, the number of seconds that have been added in this given frame that we just processed. And so now if I refresh my game, I get an accurate representation of how long the game has been running for. So this is really good. So I now have time readily available to me. What I need to do is send time to the systems that now need it, because clearly my falling blocks they're not working, and my player movement is not working correctly. So in that regard, we are going to pass delta time into our update player and our update blocks function. So we'll pass in DT and we'll pass in DT. Perfect. We'll also note here we have a new function inside of this draw function here, update ramp values, and we'll use that coming up to update our ramp, our difficulty ramp. But for right now, let's move to mission number 3. Mission 3 finds us in one of those broken systems. That broken system is our update player. You can see update player is expecting to get a delta time passed to it, DT, how much time has elapsed. Well, right now it says player cooldown timer. Apply delta time to the player, move down cool time. I can read. Wow, I can't use a calculator and I can't read right now. We're going to try to fix that. Apply delta time to the player move cooldown timer. Oof. That felt really good reading that correctly. We're going to convert movement delay from frame-based to time-based. See, right here we're subtracting 1. We call this every single frame of the game. Remember, we're calling update player every frame of the game because it's inside draw, which gets called every frame of the game. Well, every frame of the game, I don't want to decrease 1 from our cooldown timer because this is now time-based. So instead, I'm going to decrease it by dt, that little bit of time that has elapsed during our frame. So now, just by making that small little change, our movement system should be back in action, and it is. So now I'm moving at the correct rate. We just have to apply a similar change to these poor falling little blocks, and hopefully that's what mission number 4 is going to have us look at. And look at that. Mission 4 puts us in update blocks. We have to now work on our block timers. So we're going to apply delta time to the block, spawn, wait, and fall timers. So we got to do it for 3 different timers. We're going to convert block timing from frame-based to time-based. So let's do our spawn timer first. So right now we're subtracting like 1. That's every single frame. So we're subtracting frame-based. We want to subtract time. So we're going to do dt. And if I fix that, well, now our blocks should just spawn. Look at how quick they're spawning. Let's check it out now. All right, so there's one spawned. Okay, so they're spawning at a more regular rate. I mean, it still feels off. I don't know. That just doesn't seem right. But it's probably because we're going to control our spawning using that difficulty ramp, and I bet our starting values are off. But at least they're spawning more regularly here. They're moving not correctly. So let's now scroll down a little bit more, and let's look at our wait timer. So our wait timer, how long are they going to wait up there once they spawn? We'll put that to dt. And our fall timer, we'll move that by dt. So we'll subtract those timers by seconds now because everything is time-based. And let's check it out. So we should spawn and then wait. All right, there we're waiting. We're waiting. All right, and now they're moving down. All right, and so that system seems like it's now working. But we are going to control the difficulty of this game now using a ramp. And so what are some of the things that we are going to control that can increase the difficulty of our game? Well, we'll first start by controlling how fast the blocks are going to move down the screen. As the game gets harder and harder, they're going to move faster and faster and faster. Also, how quickly are we going to spawn blocks? Like, you know, look at there was quite the delay there. And how many blocks will we spawn all together? So those are some factors that we can control in our difficulty ramp. Let's go look at mission 5, where we set the constants for that difficulty ramp. So mission 5 finds us here in the student edit zone, right? Here is our student edit zone where we can modify some values. These are like knobs or dials that we can tune, turn it up, turn it down to change how a system feels or plays within our game. And this time we are going to change our ramp system. So let's look at what we have here. First, we have a variable called ramp time seconds. Ramp time seconds is going to represent the amount of time it takes for your game to reach maximum difficulty. So right now we have it reaching maximum difficulty in 25 seconds. I think that's way too short. In fact, I am going to make it, let's do 240 seconds. So our maximum difficulty will come in 240 seconds. So 240, there's 60 seconds in a minute, meaning we will reach our maximum difficulty after playing 4 minutes of our game. If you can survive 4 minutes, at that point, the game will just stay as hard as it's going to get. You just have to keep playing and surviving. So I think that's pretty good here for this type of puzzle game. Now, the way we're going to reach that maximum difficulty is by targeting 3 specific areas. First, we're going to target how quick our block falls. So this is our block fall interval. So when we start our game, it's currently set to like, we're going to wait 1.25 seconds. And then at the end, we're going to wait 1 second for our blocks to fall. Like right now, I'm waiting 1.25 seconds for that block to fall. That's just way too stinking slow, way too slow. So when we start the game, I want the blocks to fall every 0.65 seconds. And by the end of the game, they're going to move super fast. I'm going to have them fall every 0.14 seconds. So let's just see if that changes the rate of falling right now. Okay, so that's a lot better to start. So this is going to be like my starting speed of falling. And by the end, they're going to be moving Well, let's just set it to 0.14. Let's see what it's going to look like at the end. So here it is going to be at the end. Yeah, that's pretty good. That's a good fall speed. So I like that range. This, you can still respond to this. It's just going to be a lot more hectic, which is exactly what I want at the end of my game. So I think 0.65 and 0.14 are a great range here, or somewhere within that interval. Okay. The next variable that we're going to target is our spawn interval. So how quickly or how readily are we going to spawn blocks? So at the start of our game, we're going to spawn every, let's do 1.5 seconds. And by our end of our game, we'll spawn every 0.5 seconds, so 0.50 seconds. So this is going to sort of like give the user like how much time they have to sort of view and think. So you can see right now we're spawning every 1.5 seconds. All right, so it's going to land. Perfect. All right, so that looked pretty good. All right, so we wait like 1.5 seconds from it reaching its bottom row. Let's just make sure that that's right. Yeah, I think that is right. I think that's right. If I change this, let's make it like, I'm going to make it like something ridiculous, 10.5. Let's set it to 10.5. I'm going to have to wait 10.5 seconds for this first one to spawn, so I'm going to pause the video. Okay, so my first block just spawned, and let's see what happens when this block lands. Okay, so yeah, that's right. The spawn interval is 10.5 seconds from when the last one spawned. So if you look, once 10.5 seconds has fully elapsed. So that's actually going to work out pretty nice because it's going to take into account the time it takes for the block to fall here. So I'm pretty happy with that. So let's set the spawn interval start to be like 1.5 seconds and our ending to be a half a second. And I think that'll work out pretty good, especially when the blocks start speeding up. See, right now we're just keeping them at their starting values, but we'll eventually scale them to their ending values as well. And then when we start the game, we're going to start with just spawning one block, and by the end of the game, we will spawn 5 blocks. So we'll spawn 5 blocks, 1, 2, 3, 4, 5. So by the end of the game, we'll only have one open column here when the blocks are spawning. All right, so those are going to be the values that we use. So now the question becomes, how do we sort of go from a starting value to an ending value? Like, how are we going to go from, let's see, a fall interval of 0.65 seconds to 0.14 seconds? Well, the way we do this is by creating something called a difficulty ramp. And this is going to bring us to mission number 6. So mission number 6 finds us in update ramp values. It says define the ramp value from runtime seconds. Normalize it between 0 and 1 over our constant ramp time seconds, which I believe we set to 240 seconds. So before we do this here, you can say here, I'm going to go look at my gameplay variables. We've got a ramp. We have a block fall interval seconds, a block spawn interval seconds, and blocks per spawn. Perfect. And then we also have a spawn timer seconds variable. Now, these are going to be our ramp controlled values right here. We're going to control our block fall interval, our block spawn interval, and our number of blocks per spawn based on this ramp. These are the things we're going to make change to make our game more difficult. So the first thing we have to do is create a ramp. So what exactly is a ramp, a difficulty ramp? Well, to help explain it, let's go to the whiteboard. We're going to come here to our whiteboard. And so a ramp, we'll just start off by saying a ramp, let me grab my blue color, perfect. So a ramp is a value from 0 to 1, okay, from 0 to 1. So maybe it's 0, maybe it gets bigger to like 0.2, we'll say 0.25, maybe it becomes 0.5, maybe it becomes 0.68, maybe it's 0.91, or maybe it is 1. But the key idea here is that when the ramp is 0, this is the start of our game, start. And when the ramp is at a value of 1, this is when we are at a maximum difficulty. And in our case, that is at 240 seconds. That's what we set our ramp time seconds to. And so as we play our game, we are going to increase the ramp. And the ramp's midpoint between 0 and 1 is 0.5 would come at a time interval t of half our max difficulty time. It would be at 120 seconds. And as time goes on and keeps growing, the ramp gets bigger and bigger and bigger. And we can use this ramp to control the difficulty of certain factors. And so the way we can do that is by let's create a graph. And on the bottom here, we're going to put ramp. And so our ramp value goes from 0 to 1. Perfect. And on the y-axis, we are going to put something that is controlled by the ramp. So maybe I'll put fall interval. Fall interval. Well, I know my fall interval is going to start at, what did I think? We had it set to 0.65. So I'm going to say, all right, when we start the game, we are going to be moving every 0.65 seconds. And at the end of the game, I think we said our lowest value is going to be 0.14 seconds. So I have 2 data points, essentially. When the ramp is 0, remember, the ramp being 0, this is the start of the game. Our fall interval is 0.65 seconds. And when our ramp is 1, this is at our max difficulty when we are at 240 seconds. Our fall interval, we said we wanted it to be 0.14 seconds. So those 2 points here define a line. So I can draw a line, and you can think of that line as a ramp. And so as our ramp gets bigger, and our ramp is going to get bigger as we play more of our games. So if we were at 120 seconds, well, now our ramp's value is going to be 0.5. So we can come up here to our graph. Where we had our graph, we read across, and we can get our fall interval. And I have no idea what this might be. Maybe it's going to be like 0.35 seconds. As our ramp changes, we play a little bit more. Now it's like 0.6, or we'll say, what is this, 0.75. Our ramp is going to change, and our fall interval is going to get smaller. Our game's going to get harder. So maybe now it's like 0.21 seconds. All right. And so our first question is, how do we generate these ramp values, these values between 0 and 1? Once we have them, we can create a line that is going to allow us to scale the difficulty of certain factors. And that process is known as linear interpolation. Interpolation. And we have a really nice function that allows us to undergo linear interpolation, and it is called lerp. We're going to do some lerping, and let's see how this all ties together now in our code. So the first thing is we got to create our ramp. Our ramp's value has got to be between 0 and 1. Okay, well, I mean, I could just make it 0, and then I'd always be at what? I'd always be at this one particular point on our difficulty ramp. I'd always be right here. So our fall interval would always be 0.65 seconds. I can make it 1, and then we would always be right here. Our fall interval would always be 0.14 seconds. I could make it 0.5, and then our fall interval would always be 0.35 seconds. But we do not want that to happen. Instead, we want the ramp value to constantly change, right? We want it to go from 0 to 1. And so the way we're going to do this is with runtime seconds. So runtime seconds is runtime seconds. So runtime seconds is a measure of how long the game has been played for. So, 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, etc., etc. But we're going to divide that now by ramp time seconds, tab for autocomplete. This is the time we said we wanted it to take for our game to reach maximum difficulty. So let's get out a calculator. Let's see if I've learned how to use this. If runtime seconds, the game starts at 0, 0 divided by 240 is 0. So our ramp value is 0. Let's say I've played the game for 60 seconds. 60 divided by 240 gives me a ramp value of 0.25. So that means I would be like right here on my graph. I'd come up and read it, and fall interval will have changed. If we were at 120 seconds of play, 120, I thought I knew how to use a calculator. Let's try it. 120 divided by 240 is 0.5. So now my ramp value is 0.5. I can come up here, and my fall interval will have changed. And this will go all the way until I reach 240 seconds. 240 seconds divided by ramp time of 240 is 1. So we have reached our maximum difficulty. There's just one slight problem. What if I don't die right then? What if I played and I got to 250 seconds? Well, 250 divided by our ramp time of 240 is 1.04. I don't have 1.04 because we defined a ramp as being a number between 0 and 1. So I have to somehow keep this value between 0 and 1. And the way that we're going to do that is with the constrain function. So let's constrain our ramp value. All right, so the constrain function takes the value of what you want to constrain. We want to constrain this, and we're going to constrain it between a lower bound of 0 and an upper bound of 1. Awesome. So now I have that ramp built for me. So mission number 7 says, let's use that ramp to control our fall speed. We're going to use linear interpolation, or the lerp function, to scale the block fall interval. So remember, we had a couple of variables that we could use for our ramp. We had block spawn interval seconds, blocks per spawn, and then the one involving the fall interval was called block fall interval. Right here, I'm going to hit tab for autocomplete. Block fall interval seconds. How many seconds do we want to wait in between moving from one row to the next as the block is falling? Well, that is going to be a ramp controlled value. And so we are going to do linear interpolation. When you use lerp, you have to provide 3 pieces of information. The starting value, ours is going to be 0.65 seconds. The ending value, this one right here, ours is going to be 0.14 seconds. And then your location in the ramp, okay, where you are on the x-axis. So we have the starting, the ending, we can draw a line, and then we know where we are on the x-axis, so we can read the value off that line. Well, our starting and ending values are constants in our ramp system. I have block, fall, interval, start. It's that second one right here, because these are in alphabetical order. And then I'll do block, fall, interval, end. The first one here in alphabetical order. And then we need our ramp value. Well, that ramp value we just defined, it is ramp. So if we run this game, we should see or feel our blocks speeding up. Are they speeding up? I really don't know. Maybe they are, maybe they're not. It's hard to tell what is going on. I wish we could sort of like see all the details of our ramp. Well, my wish is about to come true because mission number 8 brings us to the HUD. Draw a HUD. And in our HUD, we are now showing all this great stuff like our title, our score, the amount of time that we have been playing. And now we are going to do a ramp readout. We want to display the Broshi ramp readout near the top of the screen. And this is going to show time, ramp percent, current speed values, all that good stuff. I have a function right below called draw ramp readout. And in here, we work to show the current status of our difficulty ramp. Those instructions are written. All we need to do is call or run those instructions. And I will do it right here inside mission 8. So I'll say draw ramp readout. There's the name of the function, parentheses to run the function, semicolon for good JavaScript. So let's refresh the page now, and you can see those ramp values appearing right here. So right now, the time is going, perfect. I have my ramp percentage. My ramp is at 2% right now. I have my fall interval. I have my spawn interval and the number of blocks per spawn. So let's see, as the game goes on and our ramp increases, we should see these variables change. So right now we are at a ramp percentage of what, about like 10%. I'm going to pause the video and let the game increase, and then we'll come back and we'll see the changes in our ramp. Okay, so right now my ramp is at about 38%. Oh, look, we just switched to spawning 3 blocks, so that's being controlled. The fall interval, they're moving every about 0.44 seconds. They're moving down, so they're moving faster and faster and faster. So it looks like this is working. Our spawn interval here, I think, is sort of acting just as like a catch because these blocks are taking more than 1 second to reach the ground, but that might change. So we'll keep it in there for right now. Let's pause it again and let's see what it looks like. So we're like at 50%. Let's see what we get to when we get closer to our max time of 240 seconds. So I'll be right back. Okay, so we've been playing for about 215 seconds here. I'm now spawning 5 blocks at a time. My ramp is at 91%. Once we hit, let's see, our max value, we will be done. So we've maxed out our spawn, but our fall interval and our spawn interval, you can see we're spawning a lot faster now. So that's working here on this back end. And this is getting crazy. I should clearly have died at this point. So if we get this far, now it's where our spawn interval is really triggering here. And good, our ramp is at 100% now at 240 seconds. Clearly, I don't have the game over condition in here, so we're going to force that game over with the G key. Oh no, there we go. And when we hit enter, the ramp resets. Everything goes back to its beginning. So this is really, really perfect. So we are set here now to continue building out our game. We've switched from that frame-based system over to a time-based system, which is going to create consistent gameplay across every computer. And we've successfully implemented a difficulty ramp that is going to scale our difficulty. And we're looking at 3 factors here. How fast are the blocks falling? How quickly are they spawning? And how many blocks are we spawning in each wave? So this is making for some really fun and challenging gameplay. We'll pick up here in our next video. I'll see you then.